Welcome to the Explainer. You know that totally magical feeling when you type a prompt into ChatGPT or Gemini and almost instantly a beautifully written, perfectly structured essay just spills out across your screen? Well, let's dive into that. Because that feeling of magic, that sense of awe, is exactly what we're dissecting today. We're going to pull back the curtain and look at the exact anatomy of how these systems actually operate. So, is there a ghost in the machine? I mean, it's so easy, almost human nature, really, to fall into this illusion that there's some contemplative digital brain sitting on a server somewhere, reading your words, truly grasping their meaning, and then thoughtfully and deliberately typing an answer back to you. It really does feel like a real conversation with a hyper-intelligent entity, doesn't it? But we absolutely have to separate human magic from machine reality here. Human cognition involves actual thinking, deep understanding, and lived experience. The reality of large language models, though, it's vastly different. They do not think or understand in any human sense whatsoever. At their core, they're really just playing a highly mechanical, lightning-fast game of probability. They are simply the world's most advanced autocomplete systems.
So here's our blueprint to the AI factory. We're going to track a single prompt through 4 distinct mechanical phases. Phase 1 is the shredder. Phase 2 is the meaning matrix. Phase 3 is the brain. And finally, Phase 4 is the casino.
Let's start right off with Phase 1, the shredder, where we translate text into numbers. Look, AI literally cannot read English or Spanish or even computer code. It only understands math. So the second you hit send, your prompt immediately hits what's known as the tokenizer. You can think of it exactly like a high-tech paper shredder. It digests your text by violently chopping it up into smaller pieces called tokens. And then, each of those chopped up pieces is assigned a specific unique ID number from the AI's massive internal dictionary. And here's the kicker. A token isn't always a nice, clean, full word. Sure, a simple word like apple might just be one token, but take a complex word like unbelievable. The shredder chops that into 3 separate tokens, un, belief, and able. Each tiny segment gets its own unique ID number. So your beautifully written, thoughtful sentence is now completely stripped down into nothing but a raw sequence of ID numbers. Moving right along to Phase 2, the meaning matrix. This is where we map out those tokens. Okay, our prompt is now just a string of numbers. But numbers alone don't hold any real-world meaning, right? The number 402 doesn't naturally relate to 908. So the model has to map them out in the embedding layer using something called a vector. Think of a vector as a coordinate on a massive, multi-dimensional map of human concepts. The model takes every single shredded token ID and plots it as a distinct coordinate in this immense, crazy space. And notice how the AI grasps context here without actually knowing what any of these words are. It does it purely through spatial relationships. On this massive conceptual map, words with similar meanings are plotted literally right next to each other. King and queen sit side by side. Cat and dog are clustered really tight. The model learns human context just by measuring the mathematical distance between these numbers. Which brings us to Phase 3, the brain. Enter the transformer blocks. Now that our numbers have mapped out context, they get fed into the heavy machinery. This is where the model does its absolute heaviest lifting, using an incredibly powerful tool called self-attention. Basically, self-attention is a mathematical mechanism that calculates exactly how much importance or attention every single token should give to every other token in your entire prompt. It's the glue that ties all those separate, shredded numbers together into one cohesive thought. To make this a bit more tangible, think about reading a detective novel. When you read the word he in chapter 5, you have to look back at previous sentences to figure out if he refers to the detective or the suspect. The self-attention mechanism does exactly this, but entirely with math. By calculating relationships across dozens and dozens of layers, the model builds a deeply nuanced structural understanding of your original prompt. And finally, Phase 4, the casino. Time to predict the next token. All right, the model has shredded your words, mapped their contextual meanings, and calculated all those complex relationships. Now, it has one singular focused goal: predict the very next token. It does this by spitting out a massive list of probabilities for every single token in its entire vocabulary. If your prompt was "the cat sat on the math might calculate a 70% probability the next token is Matt. That's a super mathematically safe bet. Maybe there's a 15% probability it's floor and a 10% probability it's couch. But check out this probability right here, 0.001%. The model is so vast that it calculates the odds for absolutely everything, even total wildcards. It calculates a tiny fraction of a percent chance that the next word should be moon. The cat sat on the moon. It's incredibly unlikely, for sure, but that mathematical possibility is calculated and sitting right there on the casino table. So, how does the AI actually choose the winning word? Well, it doesn't always just blindly pick the top 70% answer. The choice is actually dictated by a parameter called temperature. Temperature controls the creativity or the randomness of the model's choice. Set the temperature really low, and the model acts super predictably, picking that safe mat every time. Set it high, and it flattens out those probabilities, taking a gamble on a wilder, way less predictable word. So, the casino spins the wheel, applies the temperature, and boom, we get our word. This creates a massive, relentless 4-step loop. Step 1, pick the next token. Step 2, type it on the screen. Step 3, add that word to the original prompt. Step 4, run the entire chain all over again. All of that incredibly dense math happened just to pick a single word. And as soon as it's done, the loop instantly restarts. Let's actually simulate this. Imagine zooming out from all that math back to the user interface. You're sitting there looking at your screen, and the machine types the very first word, the. Instantly, it feeds the word the back into the prompt, shreds it, maps it, runs it through the attention blocks, rolls the dice at the casino, and outputs the second word, cat. The sheer, staggering speed of this machine is almost impossible to comprehend. It runs that entire 4-phase process all over again in milliseconds. The cat sat, this insanely complex mathematical loop is happening thousands of times a minute, over and over, word by word, token by token. The entire factory just runs continuously until your full essay is beautifully generated right there on the screen. Which leaves us with the ultimate, kind of provocative question here on our final slide. Is all of this just a high-speed illusion of probability? Or, as we continue to build more and more complex models, is this incredibly fast mechanical loop actually the new definition of thinking itself? It's a genuinely fascinating paradigm shift in how we understand intelligence, language, and computation. I hope this explainer shed some light on the literal magic behind the screen. Thank you so much for joining me. Keep exploring, and I'll see you on the next one.